Bam! Look, there's the answer. How about that? That's not too bad, is it? Okay, we've got the force that is exerted on the tires by the weight of the car. And we've got the surface area between the tire and the road. Okay, so what pressure will the air inside have due to the car's weight? So we've got 15,000 newtons exerted on 12.7 meters squared of area. And that's going to give us 1,180 pascals. Okay? All right. Now, thinking about the car and the pressure inside the tire pushing out. Okay? Remember, if you have a tire and you've got that pressure pushing out in all directions inside the tire, okay? What do you think would happen to the pressure in the car's tires if you load the car with a lot of luggage or people? What would that do to the pressure inside the tire? Oh, more bells they're testing. More tones. Ugh. All right. What do you think? Well, if you said that more weight will increase the pressure, well, then you're absolutely right. Because if you increase the weight, increase the force, but the surface area is the same, then when you divide, you're going to get a bigger quotient. All right, a bigger number divided by the same number on the bottom, you're going to get a bigger answer. Okay, so it's going to increase the pressure. All right, now, so we understand what pressure is. Pressure is the force exerted on a surface area, the force per unit surface area. How does that help us with Mr. Pascal? Okay, now that we understand, let's go back and look at Mr. Pascal. Okay, he said that pressure applied to a fluid, a force exerted down on the surface area of the fluid, is transmitted equally throughout the fluid. It doesn't diminish. Okay, well, let's take a look at the next page. So look at this right here. Here we have that here we have our cylinder with a liquid in it, and we've put a little, I guess you could call it a little slab of something, like maybe wood or something, with a weight on top, and that's pushing down on the fluid, okay? In fact, this little insert right here, this is called a piston. It actually has a name. It's called a piston. Now, with the weight of the piston and the block that's sitting on top pushing down, the liquid is under pressure. And that pressure is exerted back on the piston and equally on the sides of the container and on the floor of the container. So Pascal said that the amount of pressure exerted on this wall, okay, the amount of pressure exerted on wall 1 and the amount of the pressure exerted on wall 2, the amount of pressure exerted on the floor and back on the piston, all of those are equal to each other. Okay? The pressures are all the same. And it comes from this right here, from the weight, the force acting on the surface of the liquid. Whatever that pressure is, it's transferred throughout the fluid equally, undiminished. Now, this piston is very important in our everyday lives. This piston is what helps us do things. For example, in your car engine, there are cylinders like this with pistons in them. Here they are. I'm going to mark one there and one here. All right? And the pistons, from the explosion of gas inside the cylinder, The pistons are pushed back and forth, creating motion. And that motion is transferred to the wheels of your car. So all these pistons go back and forth alternately like this as the droplets of gas explode in the chamber and push on it. They exert a force on the piston and they push it down, okay? So they go back and forth. But that's because you've got a pressure, a force on the surface area of the piston exerted by the exploding gas pushing it, okay? Now, when it comes to looking at the pressure and what it can be used for, we can look at something as common as a hydraulic lift in a mechanic's garage. This funky U-shaped container is actually everywhere. We couldn't get along without hydraulic lifts. They just help us so much because we can exert a little force and get out a lot of force. We can push a little bit on the piston on one end of this funky container, and it actually will lift a large amount of weight on the other end. So what you have is a funky U-shaped container with fluid in it. Usually it's some kind of hydraulic oil. And you've got one side is skinny and has a small surface area. Okay? This is the surface area we're going to be pushing in on. The piston on the other end, the wide end, has a larger surface area. And that's the surface area that gets pushed out on, or in this case, up. We're going to exert a force on this surface area. So we're going to call that the force that we put in. And it doesn't have to be very big. But what we're going to get out is a lot of force. Okay? Now how can that be? How can you push in? How can you get push with a small force on a small surface area and you get a lot of force out from a larger surface area? How does that work? Well, you got to remember, Pascal said the pressure gets transferred undiminished. So as it comes around, as the force exerted on the molecules of the liquid come around, each molecule of surface area gets the same amount of force that the ones over here did. Only there's more of them, so you get more force out because you have a bigger surface area. Look right here. We have the pressure one on this side, the small force in over the small surface area pushed on, equals the large force we get out from the larger surface area that's pushed out. Now, those two ratios have to give us the same value. So to do that, we can actually have a small in and a larger out. Look at this. Suppose we push with 5 newtons of force, and let's say that was 0.1 meters squared. You know, about this big. 0.1 meters squared, all right? We push with only 5 newtons of force. That's not a lot, okay? That's not a lot of force at all. And we get 0.1 meters squared. To have the same ratio, if we know our output piston has a surface area of 3 meters squared, like what's under a car, we can actually get 150 newtons of force. That's because this ratio, if you divide, has a value of 50. This ratio also has a value of 50. So the two are still the same. So that's how we can have a small amount of force on a small area turned into a large amount of force over a larger area. Pascal said that the force is undiminished. Every molecule gets the same amount of force. And since we have more molecules lined up here, we end up with more force exerted on the larger piston. That's kind of cool, isn't it? Okay, one more example and then we'll stop, I promise. let's look at this. Suppose that you're in a mechanic's garage and you have a car that weighs 3,700 newtons. To lift it up, that means we need an output force of that much. We need to get out this much force from our hydraulic system. Now, the piston under the platform of the car has a size of 2.8 meters squared. That's going to be the out area of the surface piston. That's the out piston. The piston the mechanic pushes has a small surface area. That's going to be in. And we want to know how much force must the mechanic exert on this smaller piston in order to get out this much force. So we want how much force in should we have. Okay, well, we're going to use Pascal's principle right here. Watch this. We know that the force we put in on the input piston must equal the force we get out from the output piston surface area. Okay? Now, we want to solve for this. We're dividing it by the input area on the small piston. So we're going to multiply both sides by that. We'll always do the opposite. This is being divided, so we multiply both sides to get rid of it. So now the input force is going to be the output force divided by the surface area of the large piston times the surface area of the small piston. So that's going to be 3,700 newtons. Over, okay, 3,700 newtons. Maybe I better focus in a little bit more. There, that better? 3,700 newtons over, the big one was 2.8 meters squared, times the small one, which is 0.072 meters squared. Okay, so you say 3,700, divide by 2.8, and then take that and multiply by 0.072. What do you get? You only have to exert 95 newtons of force. Okay? And that would be about like lifting I'm going to say about a 15-pound bag of sugar. Okay? All right, so if you push down that hard on the input piston, it'll actually lift the entire weight of the car up. So put in a little force, get out a lot of force, just by using fluids. Now that's kind of cool, isn't it? All right, thanks for listening. Bye-bye.